Hi, good day. So for today's video, we are going to discuss hyperbola. And again, I'm Sir Paul Joral R. Santos from the Senior High School Department of Dasmariñas Integrated High School. For our objectives, at the end of the lesson, you should be able to define a hyperbola. That's the first one. The second one is for you to determine the standard equation or the standard form of equation of a hyperbola. And the third one is to graph a hyperbola in a rectangular coordinate system. So let us define a parabola. Say we have f sub 1 and f sub 2 be two distinct points. Distinct means different. A hyperbola is a locus of points P whose distances from f sub 1 and from f sub 2 differ by a particular constant. Unlike the definition of ellipse, where its difference from the definition of ellipse is the keyword here differ. For ellipse, it is sum up to. But for hyperbola, the distances from P of f sub 1 and from f sub 2 are uh, differ to or by a particular constant. Now, to illustrate, or by the way, the points f sub 1 and f sub 2 are called foci of the hyperbola. And we have here an illustration. Let us just say we have here a point P. Okay. Now, f sub 1 here to P, let us just say its distance, or let us denote the distance between f sub 1 to P by L, and from f sub 2 to P be M, as you can see here. So L minus M is equal to a particular constant. Now, if I have here another point P in the middle between V and or the vertex V sub 2 and P, say I have here a point uh, P, okay, its distance from f sub 1 minus its distance from f sub 2 again differ by a particular constant. Okay? The difference that I obtained from the first one is the same as the difference that I will obtain from the second one. Okay? So that is what the definition tells us. Okay, now let us have the standard equation of a hyperbola. Let C be the center of the hyperbola with the coordinate HQ. The standard form of the equation of the hyperbola is given by, okay, it is given by the square of x minus h all over a squared minus the square of y minus k all over b squared is equal to 1. If the hyperbola is horizontal. Now, I would like you to take note the difference between the hyperbola that is horizontal, or the equation of the hyperbola that is horizontal, and the equation of the hyperbola that is vertical. Okay? As you can see, the x minus h here comes first in the first equation, while for the second equation, y minus k comes first. And you have to take note that they have the same, or they have different signs. The positive one should be written on the left, or it should comes first before the negative one. So whatever the positive one between these two, it should be the first one to be written. Okay? Now, unlike the standard equation for the ellipse, okay, A and B here are not, or we do not change the positions of A and B here. And in other words, A here in this case is comes first before B. Okay? Now, what if the standard equation of a hyperbola, or what will be the standard equation of a hyperbola if the center is located at the origin, 0, 0. Okay? Now, the standard form of the equation of the hyperbola will be, as you can see, I just remove negative h and or minus h and minus k on the original equation, because those are just 0 and 0. Also, same goes with if the hyperbola is vertical. As you can see here, minus k here and minus h here were removed from the equation. So uh, take a look carefully, no? Because at, take a look carefully at this equation because you need to be familiar with these so that at a glance of an equation, you should be able to tell if it is horizontal or vertical. You should also be able to tell if or where the center is located. In this case, the center is located at the origin, while in this case, the center is located at HK. Now, for our example, we have to determine the foci or the coordinates of the foci, vertices, and asymptotes of the hyperbola. And we also need to sketch the graph and include these points and lines, along with the transverse axis. Later, I will discuss what a transverse axis is, the conjugate axis, same goes with this, and the auxiliary rectangle. Later also, I will show you how to form an auxiliary rectangle. Now, let us proceed to our first example. Y squared over 144 minus x squared over 25 is equal to 1. Now, by observing, we can say, or it can be seen that the center is located at 0, 0 or at the origin based on what based on what I have presented earlier. Okay? The center of the hyperbola is at 0, 0. Also, by observing, we can say that the hyperbola is vertical because y comes first, no? Since y comes first, therefore the hyperbola is vertical. Now, let us determine the coordinates of the foci. There are two foci here. Now, let's see, having the coordinate HK be the center of the hyperbola. The foci of the hyperbola are located at. Now, the question is, which of these formulas are we going to use? Is it the first one or the second one? Now, as you can see, the second one tells us that this will be the formula if the hyperbola is vertical. And we all know that the hyperbola is vertical. But again, we do not know yet the value of C. We all know the value, or we now know the value of H, and that is 0, and K is also 0, but C is not yet known. Okay, to solve for C, okay, we have this formula. Take note that this formula for C is different from the formula for the ellipse. For the ellipse, we have here minus, but for the hyperbola, we have here plus. The square root of a squared plus b squared. Take note that a squared comes first, so that will be 144. And b squared is the second one, or the second denominator. So that will be 144 plus 25. And 144 plus 25 will give us 169. And the square root of 169 is 13. So we now know the value of h, we now know the value of k, we now know the value of c. Therefore, we can use those values as a substitute for h, k, and c. By doing so, I have heard this. So h 0, k 0, c is 0, or c is 13. Same goes with this. The only difference is this is subtraction and this is addition. Now, performing the operation or simplifying this will give us 0, negative 13 and 0, 13. Now that I will just put it on the top, no? Okay, the foci, the coordinates of the foci. Let us now solve or determine the coordinates of the vertices. The vertices of the hyperbola are located at, okay, again, we will be using the second one because the hyperbola is vertical. To solve for A, because we do not know yet the value of a, and we will be using it to solve for or to know the vertices of the hyperbola. But as I have mentioned a while ago or earlier, a squared comes first. So that is 144. A squared is 144. So the value of a is 12. Now, replacing h, k, and a by their values, I have here 0. Okay, using the second one, no? 0, k is 0, a is 12, h is 0, k is 0, a is 12. Now, performing the operation or simplifying this, it will give us the vertices or the coordinates of the vertices at 0, -12 and 0, 12. Okay, moreover, the line segment whose length is 2a, okay, that connects the vertices of the hyperbola is called the transverse axis. Meaning to say, if we connect these two vertices, we will call it transverse axis. So that is the definition of transverse axis, the line segment that connects the vertices of the hyperbola. Okay, now let us have the endpoints of the conjugate axis. But what is a conjugate axis? A conjugate axis of a hyperbola, first, it is a line segment. Second is perpendicular to the transverse axis. So we already have an idea how it look like, no? Whose length is 2b and its midpoint is the center. Okay? Later I will illustrate that. Now, how are we going to determine the endpoints of the conjugate axis? It is given by, okay, the first one is if the hyperbola is horizontal, and the second one is if the hyperbola is vertical. And again, it is obvious that we are going to use the second one because the hyperbola is vertical. Okay? To solve for b, because we do not know yet the value of b is 25, or b squared is 25. So since b squared is 25, b will be equal to 5. Okay, and substitute h, b, and k by their values, it will be like this. 0 minus 5, 0. 0 plus 5, 0. And simplifying this will lead us to negative 5, 0, 5, 0. So these are the coordinates of the endpoints of the conjugate axis. Okay, but we are not yet done, no? Because we will determine the equation of the asymptotes. Again, let's see, having the coordinate hk be the center of the hyperbola, the equations of the asymptotes are, okay, again, we will be using the first one if the hyperbola is horizontal, while the second one if the hyperbola is vertical. And obviously, we will use the second one, okay, because the hyperbola is vertical. Using the second one, it will lead us to, okay, take note that A is 12, if you can still remember. B is 5, based on our previous computation. And again, A is 12, B is 5. So I have here A 12 over 5. H is 0, however, H is 0, plus K, which is 0. Now, if you're going to remember, or if you're going to recall, 0 times any number will lead us to 0. And 0 plus 0 will give us 0. So we can just erase this, no? Same goes with this. Okay? We have your y equals negative 12 over 5, which is a over b, x plus 12 over 5, 0 times 0 plus 0. And this will be also 0. Simplifying this, it will give us this one. Y equals 12 over 5x and y equals negative 12 over 5x. Okay? Now we have to plot the points that we have earlier, and the points C, F sub 1, F sub 2, V sub 1, V sub 2, W sub 1, and W sub 2 are located here. Okay? Now, it's for you to graph, no? Second one is to draw the transverse axis and conjugate axis. So what are we going to do? As I have mentioned a while ago, transverse axis is the line that connects the vertices, okay? And the conjugate axis is a line segment that connects the endpoints of the conjugate axis. Since we already know the endpoints by using the computation or solution earlier, so we have here this. As you can see, okay, there is a broken line here, so that you can see, no, that I've put representing the transverse axis. This one is the transverse axis, while this one is the conjugate axis. This line segment is perpendicular to the transverse axis. That's the first one. Second is its midpoint is the center. Okay? Now, let us have the third step. Draw a pair of line segments that are parallel and congruent to transverse axis, whose midpoints are W sub 1 and W sub 2. Doing this, it will be this. Okay? This line segment is the transverse axis. The lines that are parallel and congruent to this transverse axis are this line segment. Okay, take note that its midpoint is W sub 1 and W sub 2. It is parallel and congruent, and its midpoint are W sub 1 and W sub 2. We will do it also for conjugate axis. So its midpoint is also V sub 1 and V sub 2. A pair of parallel and congruent segments to the conjugate axis. So we have here this. Now we have the auxiliary rectangle. And that will be our guide in drawing our asymptotes. So how are we going to draw the asymptotes? Draw the line that contains the diagonals of the auxiliary rectangle. So that those will be the asymptotes of the hyperbola. As you can see, if I draw the line that contains the lines that contain the diagonals, it will be like this. Okay. Now, this one here is the y equals 12 over 5x, while this one here is y equals negative 12 over 5x. It has a negative slope, while this one has a positive slope. Okay? And the last step is to sketch the hyperbola. Okay, since these are asymptotes, it will not pass through, or the parabola will not pass through this. And since the focus is here, and the hyperbola is vertical, we will draw it like this. Okay, and like this. To show you, this will be the hyperbola. Okay? Now let us proceed to the second part of our, or let us proceed to our second example. Number 2. Okay, this is our second example. It is obvious that, or it can be seen that the center of this hyperbola is located at negative 2, 6. Okay? And also, the graph or the hyperbola is horizontal because x comes first. No? We can say that the hyperbola is horizontal and x is, let us just say x is positive here. Okay? Now, after doing so, we can now determine the coordinates of the foci. Yan. And obviously, we will be using the first one because the hyperbola is horizontal. But we do not know yet the value of c. To solve for c, we have c equals the square root of a squared plus b squared. And a squared is 9 because that comes first, right? A squared is 9 and b squared is 16. And 9 plus 16 is 25, and the square root of 25 is 5. Okay, we will be using these c, h as negative 2, and k as 6 in our first formula, no? For the first two formulas here. Now, doing so, we have here h was replaced by negative 2, c was replaced by 5. So negative 2 minus 5. K was replaced by 6. Negative 2 minus 5, 6. And for this, we have negative 2, H as negative 2, C as 5, and K as 6. Then simplifying this, it will be negative 7, 6. And this will be 3, 6. Okay, so we have a negative 7, 6, and 3, 6 as the foci of the hyperbola. Okay, I will just put it there. Let us have the coordinates of the vertices. Let's see the vertex or the center of the hyperbola having the coordinate h2. The vertices of the hyperbola are located at, again, we will be using the first one, but we do not know yet the value of a. So solving for a, we have a squared is equal to the first denominator here, which is 9. A squared is equal to 9, so a is equal to 3. Since a is equal to 3, we can now substitute it to our original equation or to our formula here, no? We have here h as negative 2 minus 3 as the value of a, 6. For v sub 2, we have negative 2 as the value of h plus a, which is 3. And then we have k as 6. Subtracting these two, it will give us negative 5, 6, and this will be 1, 6. Okay, so there you go. We have now v sub 1 and v sub 2. Okay, for our conjugate axis, let us determine the endpoints of the conjugate axis. In this case, if the hyperbola is horizontal, since the hyperbola is horizontal, we will be using the first one. Okay, but we are to solve for the value of b. How are we going to solve for the value of b? That is just b squared is equal to 16 because 16 is the second denominator. So b squared is equal to 16, hence b is equal to 4. And replacing h, k, and b by their values, it will give us this, or it will give us this one. Negative 2, 6, which is k, minus b, which is 4. In this case, negative 2 as the value of h, k as 6, and b as 4. So negative 2 will, this will be negative 2, 2, and negative 2, 10. Yeah. There you go. So we have now the value of, or the endpoints of the conjugate axis. Now let us proceed to the equation of the asymptotes. How are we going to solve for the equation of the asymptotes? Again, we will be using the first one because the hyperbola is horizontal. And as you can see here, b over ax minus b over a multiplied by h plus k. And for the second one is y equals b over ax plus b over ah plus k. Replacing the variables by their values, we have this, or we have here 4 over 3, so raise it 4 over 3. Because the value of b is 4 and the value of a is 3. X minus, again, 4 over 3, h, which is negative 2 plus 6, which is k. Same goes with this. Okay, the only difference is their signs and operation. For the first one, we have here positive, and the second one, we have negative. The operation between the first term and the second term is minus, while the operation for the first, between the first and second is addition or plus. Now, doing so, we have here, or simplifying this, we have here negative 2 multiplied by negative 4 over 3 will be positive 8 over 3. Now, 8 over 3 here plus 6, which is 6 or 18 over 3. So we have 8 over 3 plus 18 over 3 will give us 26 over 3. We are just to simplify this now. And for this one, we have negative 8 over 3, since positive 4 multiplied by negative 2 is negative 8 over 3 plus 18 over 3 will give us 10 over 3. So the result is, or are, y equals 4 over third x plus 26 thirds, and y equals negative 4 third x plus 10 thirds. So those are the equation of the asymptotes. Let us graph. Okay, The center, f sub 1, f sub 2, v sub 1, v sub 2, w sub 1, and w sub 2 are located at, or are located here. Okay. Now, let us proceed to the second one. Draw the transverse and conjugate axis. The transverse axis in this case is horizontal, while the conjugate axis here is vertical. Now, draw a pair of line segments that are parallel and congruent to the transverse axis. Doing so, we have this, whose midpoints are w sub 1 and w sub 2. Same goes with the conjugate axis. And since we already have the auxiliary rectangle, we can now draw the asymptotes. Okay, this one, the line that rises from left to right. Okay, this one is y equals 4/3 x plus 26/3. While this one here, the line that rises from right to left, or sabihin na, or let us just say goes down from left to right, is the line y equals negative 4/3 x plus 10/3. Okay, so those are the asymptotes. No? And we have here the sketch of the hyperbola. Okay, again, the hyperbola is horizontal. These are the foci. Okay, the foci also serve as a guide where you are going to graph your parabola, or your hyperbola rather. Okay, so that will be the second example, and let us now proceed to the third example. Okay, example number 3, yx squared minus 4y squared minus 90x minus 32y equals negative 305. The goal is to transform the equation in standard form. Make sure that the constant term should be on the right side of the equation before performing the steps below. Okay, as you can see, the constant term here is already on the right side. So we do not need to move it to the right since it is already there. The first step is to rearrange, and what we are going to rearrange is the position of 90x and 4y squared, or negative 4y squared. Doing so, we have your 9x squared minus 90x minus 4y squared minus 32y equals negative 305. Next is to factor out. We will factor out 9 here. So that will be, we also have to factor out 4. Okay, doing so, we have your 9 multiplied by the difference of x squared minus 10x, because 90x divided by 9 is 10x. Factoring out negative 4, it will give us y squared here plus 8y. Sir, why is it, or why it became plus? Because negative 32 y divided by negative 4, it will be positive. So we have your positive 8y, or plus 8y equals negative 305. Okay? This process is similar to what we have in transforming a general equation of an ellipse to its standard equation. Okay, now let us perform completing the square, and then we have to simplify. Okay, we will add 25 here. How did I obtain 25? We will divide 10 by 2, that will be 5, and multiply it to itself will be 25. For this, we have here 16. 8/2 is 4, and squaring 4 or multiplying 4 by itself or to itself is 16. However, we should take note that 25 will or must be multiplied to 9 in this case. So that will be 9 times 25, or I added 9 times 25 also on the right side for them to be equal. Same goes with this. As you can see, we have your negative 4 and 16. Since 16 is, okay, there is something wrong with this, no? This one, or this exponent should not be, or should be erased. Okay, since 16 here is, let us just say, inside the parentheses, it should be multiplied to negative 4. So In other words, we subtracted here negative 4 times 16. Or we added here, or we subtract 4 times 16 in this case. So I have here negative 4 times 16 or minus 4 times 16. And simplifying this, it will give us this. Okay? Uh, Sir, how did we simplify it again? The square root of this x, taking the operation here, minus, and the square root of this 5. The square root of this is y. The operation here is plus, and the square root of 16 is 4. So doing so, I have here this. And simplifying the right side will give us negative 144. Now, it seems that in this case, the hyperbola is, or it looks like horizontal because x comes first and x is positive. But if we're going to divide both sides of the equation by negative 144, it will turn out to be like this. Okay, this one. This will be positive because negative 4 divided by negative 144 is 1 over 36. So I have here 36 and I put it first because it will be positive, while this one here will be negative because negative or 9 over or 9 divided by negative 144 is 1 over 6 or negative 1 over 16. So it will be negative, hence I am putting it second, no? Now, since I have here this, okay, obviously, we can say that the center is located at 5, negative 4. This is the standard equation of our hyperbola, whose general form is this. Its center is located at 5, negative 4. By the way, if you want to challenge yourself, feel free to pause this video right now and then solve it on your own before I show the solution or the answers for this. Okay? Now, if you are done with pausing, let us continue. Orientation is vertical because y comes first and y is positive. C is 36 plus 16, or the square root of 36 plus 16, and that will be square root of 52. And simplifying square root of 52 will give us 2 square root of 13. A squared is equal to 36 because the a here or a squared here comes first. So a squared is equal to 36, so a is equal to 6. While b is equal to 4. Foci is located at negative 5 or 5 negative 4 minus 2 square root of 13 and 5 negative 4 plus 2 square root of 13. And the vertices are located at 5 negative 10 and 5 2. The endpoints of the conjugate axis are located at 1 negative 4 and 9 negative 4. And the endpoints or the equation of the asymptotes are y equals 3 halves x minus 23rd halves, 23 halves. And y equals negative 3 halves x plus 7 halves. Okay, plotting the points we have here. Okay, so we are going to plot the center, foci, vertices, and endpoints of the conjugate axis in this case. So we have here these points. For our step 2, the transverse axis and conjugate axis. Okay, the transverse axis is here, and the conjugate axis is this one. And the pair of line segments that are parallel and congruent to the transverse axis are these two. While for the conjugate axis, the pair of line segments that are parallel and congruent to the conjugate axis are these two. Okay, and then so now we have our auxiliary rectangle. So we can draw our asymptotes. Drawing the asymptotes will be like this. Okay, this one has the positive slope and this one has the negative slope. And we have to sketch the hyperbola. So this is the hyperbola. The hyperbola that is vertical, whose standard equation is the square of y plus 4 all over 36 minus the square of x minus 5 all over 16 equals 1. So that is the end of our video lesson in hyperbola.